So we will be continuing with Module 2 today. And this is the elements of photography. Although hindi naman natin i-discuss lahat, but we will discuss one element today. So there are 5 elements of photography. These are the images or the subject. Ito yung kukuhanan nyo ng picture. Either tao yan, landscape, or whatever. Sensitized material. Ito yung film or your photo paper. And then we have light, as in liwanag. Diba? Nabanggit natin last time na we are not going to be able to take any kind of picture without light in it. Kasi kung walang light, puro dilim lang o puro kadiliman lang ang makukuha na natin ng picture. And then of course, yung camera, yun yung gagamitin natin para makapag-record ng images. And we have the chemical. At ito kasi yung ginagamit for the development process para ma-develop yung film and yung ating photo paper. We need chemicals. So, lesson 1 tayo dito sa light. So, light muna. Light is electromagnetic radiation within a certain portion of the electromagnetic spectrum. The word usually refers to visible light, which is visible to human eye and is responsible for the sense of sight. Madaming uri ng light, pero hindi lahat ay nakikita ng tao. Yung binabanggit dyan na visible light, yun lang yung parte ng electromagnetic spectrum. Imagine, this is the electromagnetic spectrum. Yung visible light, yan lang yung nakikita ng tao. Okay. So visible light is usually defined as having wavelengths in the range of 400 to 700 nanometers. So kahit anong nasa 400 to 700 nanometers, nakikita ng tao yan. Between the infrared with longer wavelengths and the ultraviolet with shorter wavelengths. This wavelength means a frequency range of roughly 430 to 750 terahertz. The speed of light measured in a vacuum is 299,792,458 meters per second. Meters per second ha. Ibig sabihin, ganyan kabilis ang speed of light. Hindi mo yan mahahabol. Kasi 299 million meters per second nga, di ba? Sabi dito, approximately 186,281 miles per second. Kahit na sobrang bilis mong tumakbo, kahit na athlete ka, hindi mo mahahabol ang light. Imagine niyo lang, 'di ba? Pag binuksan mo yung pinto, may papasok na liwanag, 'di ba? Kapag tumakbo ka, inanahan mo yung light, hindi mo magagawa, hindi ka magsasucceed doon kasi nga mas mabilis talaga ang light kaysa sa tao. Ganito nga siya kabilis. That is, again, the speed of light. Okay, optics. The science behind how the human eye works. It is the study of light and the interaction of light and matter. The observation and study of optical phenomena such as rainbows and the aurora borealis offer many clues as to the nature of light. Etong mga to, iba't ibang uri ng light. Pag sinabi nating optics, kung papaano nag-i-interact ang light at ang matter. Pag sinabing matter, kahit anong, anything that has space and has mass, that's matter. So kung papaano nag-i-interact ang light at matter, then we call that, or then that is part of optics. Okay. Next is the electromagnetic spectrum. Colors of the sunlight that is separated is called the spectrum. One way to see the spectrum of sunlight is by using a prism made of glass or plastic. Another way is to look at a rainbow. Ang colors ay napapaghiwalay. Kaya wala talagang forever. Kahit kulay, naghihiwalay. At makikita mo yon na naghihiwa-hiwalay kapag nakakita ka ng rainbow, di ba? Roy G. Biv pa nga ang initials ng mga colors, di ba? Then, the light is bent, and because some wavelengths bend more than others, the colors are separated. Remember yung nabanggit kanina? Ito. Ang nakikita daw ng tao ay yung nasa 400 to 700 nanometers. So, that means that these colors, itong mga to, ay nasa 400 to 700 nanometers. Kasi nakikita natin tong mga kulay na to. At kapag tumatama sila sa prism, naghihiwa-hiwalay sila. Nagbe-bend yung kulay at dahil nga sa iba-iba ang wavelength ng mga kulay, maghihiwa-hiwalay sila. So, violet rays are bent the most. And then red rays are bent the least. Ito siya, di ba? Yung sinasabi kong Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. Kung nakakita na kayo ng typical na depiction ng isang rainbow, di ba? Pag ganun sila. Red, orange, yellow, green, blue, indigo, tas yung violet pa ganun na lang. Kaya nga sabi dyan, violet rays are bent the most. Di ba, pag ang violet, nakaganyan na lang siya. Pero ang red, nakaganyan pa. Kaya nga, red rays are bent the least. Pinaka hindi nabebend ang red. Kaya nakaganon pa sa rainbow, then yung violet, nakaganyan na. Okay. Then, the whole range of radiant energy includes radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. Etong mga nabanggit ay ang buong radiant energy. Okay. Visible light, which makes up only of a tiny fraction of the electromagnetic spectrum, is the only electromagnetic radiations that humans can perceive with their eyes. As you can see, ito yung buong electromagnetic spectrum. Ang visible light, ito lang. Ibig sabihin, ganito lang kadami ang nakikita ng tao. Ito yun. Pag pina-enlarge, ito na yun. Itong makulay na ito. At lahat ng mas mababa sa nanometers na 400 at mas mataas sa nanometer na 700 ay hindi na nakikita ng tao. Okay. Again, ito ang electromagnetic spectrum. Ang nakikita ng tao ay visible light lang. Maliit lang. At lahat ng nandito, hindi nakikita ng tao. So, visible spectrum is a small part of the electromagnetic spectrum where the visible light is found. The portion of the electromagnetic spectrum that affect the human sense of sight. Visible light includes all those radiation having a wavelength ranging from 400 to 700 nanometers. So when light shines through a prism, you can see all the colors of the rainbow or the visible spectrum. Katulad nito. Kapag tumatama sa prism, naghihiwa-hiwalay yung mga kulay. Yan. In fact, daylight is a mix of all colors. Pag nagsama-sama ang mga kulay, ang makikita mo puti. So, all colors, pag tinag-add mo lahat, is equals to white. The presence of all colors. But the absence of all colors, anong kulay? Usually, anong kabaligtaran ng white?
Black, ma'am.
Black, tama. So, the presence of all colors is white. The absence of all colors is black. Okay. So, all the colors of nature come from light. So, eto yung mga approximate wavelength nila. This is not actually MU, pero wala kasi yung symbol ng nanometer. Medyo pa ganyan kasi siya, M, tapos magkadikit sa U. Anyway, this is nanometer. So, primary colors, Red, which has the longest wavelength, is 700 nanometers. And then, blue is 450 nanometers. Green is 550 nanometers. Magenta has the shortest wavelength, 400 nanometers. And then cyan is 500 nanometers. And yellow is 590 nanometers. We also have neutral colors. Ito yung black, white, and gray. Okay. Dito tayo sa primary and secondary colors. I think you know this already na ituro na ito. Elementary pa lang kayo o kaya prep kayo. So, primary colors, RBG, red, blue, green. So, white light can be made by mixing red, blue, and green. Ito yung mixture. Pag pinagsama-sama mo nga lahat ng kulay, nakikita nyo ba tong bilog? Siguro naman. Yung bilog na to is dedicated for blue, this one is dedicated for red, and this one is dedicated, green, and then this one is dedicated for red. Kaya nga nasa gitna, puti. Kasi nga, again, white is the mixture of all colors. The process of mixing colors by mixing primary colors is called addition because one color is added to another. Ayan. Then colors, secondary colors naman tayo. Colors made by combining two primary colors. So, saan to? Red plus green. Diba? Red, green. So, ang sagot dyan, itong nasa gitna, yellow. And then, blue plus green is cyan. And, asan ako? Blue plus red is magenta. Okay? So, R stands for red, B stands for blue, and then G stands for green. M stands for magenta, Y stands for yellow, and C stands for cyan. So, gets nyo na ito. Red plus, for additive color mixture, yan. Red plus green equals yellow, magenta plus yellow equals red, magenta plus cyan equals blue, so on. Subtractive color mixture, of course, magdededuct ka. W stands for white. So, white minus red is cyan, white minus blue is yellow, and so on. So, pwedeng basahin nyo na lang din yan. Okay. Color temperature. So, the color temperature of a light source is a numerical measurement of its color appearance. Color temperature ay yung itsura. Yung temperature ng isang bagay base sa kanyang itsura. When we say itsura, yung kanyang kulay. It is based on the principle that any object will emit light if it is heated to a high enough temperature, and that as the temperature increases, the color of that light will change along with the temperature. Nag-iiba ang kulay ng isang bagay kapag nag-iiba rin ang kanyang temperature. Ito yung example. If you have ever seen a blacksmith, panday, at work heating a horseshoe, you will see that the horseshoe glows red hot. Kapag ang isang bakal, tinapat mo sa apoy, mag-glow siya. Nagiging kulay pula, minsan kulay puti. Depende. It was heated enough so that it gave off light. Red light in this case. Keep heating it and it would go from red to orange to yellow to white and finally to blue-white. Ibig sabihin, ang pinakamainit na kulay ay yung blue-white. Na-imagine nyo ba yun? Na kapag may bakal na tinatapat sa apoy, ganyan ang itsura. Una red, tapos pag mas mainit na siya, nagiging orange. Tapos parang siyang nag-glow, then yellow, then white, and then blue-white. Kaya nga yung kalan, yung mga kalan na ginagamit natin, di ba, ang kulay ng apoy ay kulay blue. Ibig sabihin, mas mainit yon kesa sa pag nagluto tayo gamit ang uling. Kasi yung apoy, na lumalabas kapag uling ang ginamit natin, it's either red or orange lang. Pero yung galing doon sa ating kalan, gas stove natin, color blue or blue-white, that's hotter. Okay. A light source's color temperature then is the temperature at which the color of the horseshoe would match the color of the light source. We express this temperature in degrees in Kelvin. Kaya kapag sinusulat ang color temperature, Kelvin ang unit of measurement. Okay? Sources of light. Saan ba nanggagaling ang liwanag? We have two types. We have two sources of light, natural light and artificial light. So when we say natural light, the source of all daylight is the sun. The combination of color and contrast ascertains the quality of daylight. So, itong mga natural light ay, of course, ang sun, which is also considered a star, lightning, fire, and aurora borealis. Lahat ng ito ay natural light. Color of the daylight will also affect the appearance of the objects being photographed, especially in color photography. Factors affecting the color of the daylight: atmospheric vapor, atmospheric dust, and reflected light reach the objects and directly coming from the source. Ito, yung mga bagay na makakaapekto sa kulay ng daylight. Hindi naman iisa ang kulay ng daylight eh. Hindi naman lahat bright yellow. Hindi siya ganon. Depende nga sa mga ito. Di ba pag umaga, andyan na ang araw, pero minsan makulimlim pa rin kasi may fog. Di ba? Dito, malapit kasi kami sa bundok. Madaming umaga ang ganon. May araw na pero medyo makulimlim pa dahil may fog dito. Ayan. Okay, classification of daylight according to intensity. Kung ano ang description o ang tawag natin sa daylight base kung gaano kalakas ang sikat ng araw. So we have bright sunlight, hazy sunlight, and dull sunlight. So the appearance of the shades of the objects must be considered to distinguish this classification. First, we have bright sunlight. So the subject will produce strong shadows because the source of light is not covered and the objects or subjects appear glossy in open space due to direct sunlight and reflected light coming from the sky which act as a reflector. So isahin natin. Sinabing bright sunlight, yung subject daw in this picture, ito yon, yung puno, will produce strong shadows. Ito, strong shadows, because the source of light is not covered. Hindi natatakpan yung source of light. Sa picture na to, ano yung source of light? Saan galing yung liwanag?
Araw, ma'am.
Sa? Tama. Tama, sa sun.
Sa araw po.
Tama. So, the source of light in this picture is the sun. At sabi dito, it will produce strong shadows. O, check. Because the source of light is not covered. Ano ba ang pwedeng magtakip sa araw? Clouds. Wow, parang prep ah. So, clouds. Tama. Clouds can cover the sun. And when the sun is not covered, it will produce bright sunlight. Ano pang sabi dyan? Objects or subjects appear glossy in open space due to the direct sunlight. Kasi nga, direktang tumatama yung liwanag mula sa sun doon sa ating object or doon sa ating subject. Next, we have hazy sunlight. The sun is covered by thin clouds. And the shadow appears bluish. Because of the decrease of light falling on the subject in open space. The shadow cast is transparent to the eye, and more details are visible under this lighting condition than a bright sunlight. Okay. Sa hazy sunlight, merong humaharang sa ating light source. Ang ating light source yung sun. Ano daw yung pwedeng humarang dyan? Thin clouds. Kaya anong mangyayari doon sa mga shadow? Medyo bluish siya. Hindi siya katulad nito na ang description ay strong shadows. Ibig sabihin, deep or dark ang color ng shadows. Unlike here, hindi masyadong strong ang shadows. Anong ibig sabihin nun? Kapag may bagay na nandoon sa shadow, mas madaling makita kumpara dito. Kasi dito, sabihin na natin yung kulay na ito ay black. Kapag may mga bagay dito, mahirap makita. Kasi nga yung shadow black. Pero kung nandito sa hazy sunlight, yung shadow na gawa ng hazy sunlight ay bluish or lighter than shadows produced by a bright sunlight, mas madaling makita. Kung pipicturan mo siya, mas madaling mapicturan dito. Kasi nga, more details are visible. And last classification is dull sunlight. So the sun is totally covered by thick clouds. No shadow is cast to the uniform illumination of lights all around the subjects in open space. Hindi hindi nagkakast ng shadow yung light source natin. Bakit? Kasi yung light ay natatakpan na ng thick clouds. 'Di ba? Kapag maulan, walang shadow. Ayun. And dull sunlight, sun is totally covered by thick clouds and no shadow cast. Okay. Next is artificial light. So almost all artificial light sources can be used in photographing of objects as long as the light is capable of exposing the sensitized materials. Some of the artificial lights are electronic flash, photo flood lamp, fluorescent lamp, infrared lamp, and ultraviolet lamp. Pag sinabing artificial, in short, ito yung mga gawang tao lang. Ayan, electronic flash, photo flood lamp, fluorescent lamp, infrared lamp, and UV. Yan, those are all artificial light. Okay. Mediums of light. Pag sinabi nating medium, ito ay isang bagay. Okay. So, ano yung mga bagay na yon? Transparent objects, translucent objects, and opaque objects. So when we say transparent objects, these are mediums that merely slow down the speed of light but allow to pass freely in other respects. They transmit 90% or more of the incident light. So in this picture, ang object natin is etong wine glass. Then the source of light is the flashlight. Anong sabi dito? Transparent objects are mediums that merely slow down the speed of light but allow to pass freely in other respects. Transmit 90% of the incident light. Incident light, ito yon. Yung light na nanggagaling sa light source. Ito mismo. Yan ang incident light. Ibig sabihin, 90% nito ay tumatagos sa mga transparent objects. Okay. Ano ba yung mga transparent objects? Basta mga bagay na makikita mo yung nasa kabilang side ng malinaw. Yun. Ano naman yung translucent objects? So these are mediums that allow light to pass through it in such a way that the outline of the source of light is not clearly visible. They transmit 50% or less of the incident light. Ito ay mga bagay na makikita mo rin naman yung nasa kabilang side mula dun sa object na yon. Pero, hindi sila ganon kalinaw. Ang sabi nga, ang makikita mo lang is the outline. And it will only transmit 50% or less of the incident light. Katulad nitong nasa picture. Dito, alam natin na merong tao. Itong translucent object, itong salamin, no? Alam natin na may tao dyan. Alam natin na kumpleto yung daliri niya. Pero hindi natin nakikita kung pantay ba yung kilay niya. Hindi natin nakikita kung naka-blush on ba siya sa pagkakataon na to, naka-lipstick ba siya. Kasi nga, hindi naman ganon kalinaw. Hindi naman katulad nitong wine glass na kapag tinignan ko kayo, nilagyan ko kayo tinapat ko sa inyo ang isang wine glass, makikita ko pa rin kayo ng malinaw as compared to translucent objects. Okay? So again, it will only transmit 50% of the or less of the incident light. And then we have opaque objects, a medium that can divert or absorb light. Pag sinabi nating divert, ililiko ka niya. Or absorb light, tatanggapin niya yung light. But does not allow light to pass through. Pero hindi raw patatagusin ang light. Hindi katulad dito, tumatagos yung light. Kasi nga nakikita mo yung nasa kabilang side. Diba? Alam, syempre, sa translucent, 50%. Pero makikita mo pa rin yung nasa kabila. Unlike in opaque objects, imagine niyo to. Itong tasa na to, tinapat ko sa inyo. Hindi ko kayo makikita as in. Kasi nga, hindi naman pinapayagan ng object na to na tumagos ang light because it is an opaque object. It absorbs or it diverts light that goes to it. Ito, perfect example. So, may giraffe. Tapos, kung transparent yan, malinaw na malinaw. Kung translucent, kita mo pa rin yung outline pero hindi na ganun kalinaw. Medyo mag-iiba yung kulay. And then, kapag opaque, wala ka talagang makikita sa kabila. Okay? So, ways light can interact with matter. So, light waves travel in straight lines. When light waves encounter an object or new medium, they act in one or more of the following ways. They may be reflected, they may be absorbed, or they may be transmitted. Ito, yung mga paraan kung paano mag-interact ang light sa matter. They can be reflected, absorbed, transmitted. Nakuha yun? So, yan. Light can pass through matter. Kapag tumagos, ang tawag doon, transmission. Kapag tumagos ang light. Ito yung light ha, itong red, green, blue. Ito yung bagay. Tatagos siya. Okay. So, light can also bounce off matter. Tatalbog. We call that reflection. Kapag tumalbog. Ito yun. And light can be absorbed by matter. Ito yung bagay, absorb niya lang. Okay. O question. Kapag transparent, anong action ang nangyayari?
Transmission, ma'am.
Tama, transmission. Kasi kapag transparent, tatagos siya. 'Di ba? Sabi nga, 90% ng incident light will pass through it. Paano kung translucent?
Transmission.
Transmission pa rin.
Transmission din,
Tama. Paano kapag opaque?
Reflection or absorption.
Yang dalawa, reflection and absorption ang nangyayari. Depende na lang sa kung anong uring bagay yun, yung degree ng reflection at yung degree ng absorption. Okay. Reflection of light. So reflection refers to the rebounding or deflection of light. The angle of reflection depends upon the angle of the light striking the material, which is referred to the angle of incidence. Katulad nitong nasa picture na to. Ito yung source of light. 'Di ba? Yung flashlight. So naglagay ng salamin at tatalbog yung salamin, depende. Kung yung babae nakapaganyan, tama yung posisyon na tatalbog dun sa isang lalaki. Pero kung nakapaganyan yung posisyon ng babae, binaligtad niya yung angle ng salamin sa kabilang side, tatalbog yung light. Sabi nga, di ba? It depends, the angle of reflection, ito yon yung reflection, di ba? Will depend upon the angle of the light striking the material. This is the material. So we call this the angle of incidence. Okay. When light is reflected, it acts in a certain way. When the reflecting surface is smooth and polished, the reflection is orderly and specular or specular. Reflecting surface is smooth and polished. We call that orderly or specular. Ito yung object, di ba? Pantay siya. Specular light is reflected at the same angle of the surface as the light incident to the surface. Ibig sabihin, kung ano yung angle na to, ay siya ring angle ng mga reflected rays o angle of reflection. Kung ito ay 45 degrees, then ito 45 degrees din. Okay. That is the path of the light reflected from the surface forms an angle exactly equal to the one formed by its path in reaching the surface. Ito. Thus, the angle of reflection is equal to the angle of incidence. Nabanggit yung incident light kanina. Incident light is the light directly coming from the light source. Ito yon, incident light. Palitan natin kulay. Ito yung incident light. Kapag tumama siya sa isang bagay na orderly or specular or patag, ang talbog niya ay parehas din. Kaya nga kita nyo to, yun yung sukat niya, yung angle. Same lang siya. If the object or surface is not smooth or polished, but irregular, light is reflected irregularly or diffused. So, ito yung incident rays, di ba? Galing sa sun. Pupunta siya sa isang malubak na lugar. So, yung reflected rays, hindi mo rin mawari kung saan sila papunta. Kasi nga, tulad nito, di ba? Ito yung may arrow. Ito, incident ray pababa, tapos tumalbog din siya doon sa lugar na yun. Merong pumunta doon, and so on. Okay? Again, when a certain object or a certain surface is orderly or specular, yung incident ray, yung liwanag na galing sa light source, ay parehas doon sa sukat ng reflected rays. Pantay sila. Pero kapag ang surface ay hindi smooth, hindi polished, or irregular nga siya, irregular din ang lugar ng mga reflected rays natin. Tabi-tabingi din. Okay? Absorption of light. So when light strikes a medium and is neither reflected nor transmitted, it is said to be absorbed. Tinanggap lang nung bagay na yon yung liwanag. When light comes in contact with the surface of an object, a certain degree of reflection and some absorption always takes place. Laging may na-absorb na light. A medium that does not allow light to pass through is called opaque. Kapag nag-absorb lang, opaque yung object na yon. Then, kapag transmission, nabanggit na natin to kanina, light rays may also be transmitted. They may also pass through some medium they encounter. When objects can be clearly seen through the medium is transparent. Kapag hindi masyadong maliwanag ang nakikita mo, it's called translucent. A transparent medium transmits light rays in a regular or uniform pattern. When the medium transmits light but breaks up the orderliness of the pattern, sending the transmitted rays in many directions, the medium is translucent. Pinatagos pa rin naman daw yung liwanag, pero yung hindi daw ganun kaayos yung pagkakapatagos niya ng light. Ibig sabihin, ito ay translucent. Okay. Refraction of light. Refraction is the bending of light rays when passing through a surface between one transparent material and another. bending of light rays between one transparent material and another. When the material in the path of the light is transparent, a change in the direction of the light occurs. Katulad nitong nasa baso. Dalawa ang bagay na transparent dito at merong isang opaque. Yung opaque, yung lapis. Yung transparent, yung baso, pati itong tubig. Kahit itry nyo to ngayon, makikita nyo na hindi pantay. Na parang nahati yung lapis, di ba? Andito yung lapis. Tapos ito yung isa. Yung kalahati niya. Ganun din sa salamin ko. Pag tinignan nyo kung nakaganyan, parang may isa pa akong ganun, may isa pa akong pisngi. Kasi nga, nagre-refract dito sa salamin ko. Ganyan din. The change of the direction that occurs when a ray of light passes from one transparent substance into another substance of different density. Kapag magkaiba yung mga density na nandoon sa mga transparent objects na yon or substances. Refraction occurs because light travels at different speeds in different transparent substances. Kumbaga, iba yung speed of light dito sa baso. Iba rin yung speed of light dito sa tubig. Iba rin yung speed of light dito sa straw. Kaya nagiging ganyan ang itsura. Kasi nga, magkakaiba yung speed of light. The speed of light in each transparent substance is called the index of refraction for that substance. Then we call dispersion of light. Pag sinabing dispersed, ikinalat, something like that. The speed of light in a medium depends on the wavelength of the light. As light enters a denser medium, the shorter waves are slowed more than the long waves. Mas bumabagal ang mga maiikli ang short wave, yung mga waves. Nasa colors yon, check nyo na lang kung ano yung mga maiikli ang short waves. Kapag dumadaan sila sa mas makapal o mas mabigat na mga medium. Okay?